All right, let's get started. My name is Colton Myers. This is Joseph. I'm actually going to be doing most of the presentation. Joseph just gets credit for all my work, so nothing new there. No, but how many of you here are familiar with Salt SSH? Have used Salt SSH? A few, that's pretty good. How many of you are confident you could tell me how Salt SSH works? Okay. Well, we're going to talk about all of that a little bit today. So let's get started. So, Salt SSH. Some people, for some reason, have a problem with agents. They don't like to have agents on all of their boxes. I, for one, am not one of them. I generally prefer to run normal Salt, but if you can't put an agent on a target box or whatever, and you only have SSH access, then this is a pretty good option. And we wanted to, for a while, we said, we're more of the just use Salt the way that it is best, which is, with a Minion installed on each of your servers. But we realized that we want to rule the world, and so we want to just serve all use cases. So Salt SSH is Salt over SSH, and we're going to talk a little bit about what that is and how that works. Basically, Salt SSH is designed such that it won't modify the target system unless you tell it to, or actually, it will leave a little bit of a trace by default, but you can configure it such that it'll clean itself up after each command if you want. I don't recommend it because it makes it a lot slower, but we have been working a lot on Salt SSH in recent months and actually brought it pretty close to feature parity with normal Salt. So with 0MQ Salt, I guess I shouldn't say normal Salt. Is that so you can troll me just at random times? No, you gotta wait.
I just wanted to point out that it's about as feature parity as you can get. There's a couple things that you're not going to have access to. For instance, you're not going to have the event bus because that's just not built into SSH, and therefore you're not going to have access to the event reactor. But beyond things like that are just fundamentally not available in SSH, it's
really close.
It's there, yeah.
Additionally, we have feature parity, but Salt was not really designed with SSH in mind. So we've had to do a little bit of shoehorning of the architecture of Salt into the SSH model, the agentless model. And we'll talk a little bit about what that means and the performance implications of that. So some people are really worried about me calling minions when with Salt SSH. Technically, Salt SSH, we're not installing the Minion. I'm still going to call them minions because I've spent long enough with Salt that systems I'm talking to are minions. So, but just know that technically there's not a master, there's not minions because we're not running agents, but I'm just going to call them the same thing. So let's, we're going to jump right into the demo here. All right, so I spun up a couple of fresh new machines. Let's see here, I want that one. No. Maybe. Whoa, my cursor's all off. There it is. All right. Route 2. I'm not telling you. I don't know why this is in blue and not black.
And what is your pet's name?
What is your pet's name? We're going to make this black. It's still not working. I had this working beforehand. I just want you to be black. What is your problem? Yeah, it's probably... There we go. Okay. Sorry, I don't usually work in a light background, but it works a lot better for these projectors, so we're going for it. All right, so we're on a fresh machine. Nothing's installed. Rather than try to install from pip or anything like that, I'm just going to bootstrap it really quick. So we're going to saltstack.com out to salt.sh. Okay. And we're just going to, we don't actually even need to install the master, interestingly enough. So we're just going to bootstrap it with that. We're going to bootstrap it off of Git, because this is the version I was testing with. We're going to do the 2015.2.0 RC1. Apparently it doesn't like me. This is good. So apparently we are modifying Bootstrap since the last time I tested it. Yeah, SoundTech released 6 hours ago, and apparently it's broken. So this is good. We're going to go back to this version. Thank you.
One lesson to be learned here: Salt Bootstrap also ships with Salt itself, and you don't have Pedro coming in and making releases on you.
So those who are not familiar with Salt Bootstrap, it's a Bourne shell script that allows us to bootstrap on most of the systems on which Salt is supported, so that's pretty cool. All right. Let's still you get that one. All right, let's try this again. What is it now? I wonder if I'm actually just not even getting what I want. Oh, yeah, okay, that would be the problem. Apparently I just don't know how to use wget. I think it's a capital O. Yep, thank you. No, I think I'm confusing it with curl, because, yeah. So anyway, this demo is off to a great start. And now I just need to use the right command again. All right. We're off to the races. We recovered. All right, so this is installing Salt. It's going to install all our dependencies and install Salt from the git tag v2015.2.0 RC1. And interestingly enough, when you install the Minion this way, it will install the Salt SSH script for us. So when this is done here in a second, somebody played Jeopardy music. We'll be good. I like it. Keep it up. Keep it up, man.
I'll just let Thane cover the Jeopardy music there.
I don't care if the demons are running. Thank you. In fact, we'll kill that minion just because. All right. So now we have the Salt SSH command, assuming I can type. All right. So Salt SSH. The key with Salt SSH is now, since the minions don't reach out to us, we need to tell our master where to find these minions. The way we do that is with the roster. And so you can see here, now we have roster equals roster, roster file equals roster file. The roster system is a pluggable system, which allows us to return information, which is then passed to SSH about how to get to our minions. The default roster is called the flat roster, and it's just a flat file basically where we define the information about our system. So if we go back over here and grab that other IP, then we can go in here and say, okay, etc salt roster. That's where it's located by default. So we're going to call our minion, we're just going to call it my minion because that's easy. There's the host. We want to sign in as user root. And that's all we really need for now. We can define custom grain information here if we want to in order to be able to target by grains and that kind of thing. But
I think somebody was asking for your password there too.
Yeah, I'm not going to type my password. Sorry. Though it's a password I use just for this demo, so you wouldn't be able to get into any of my stuff anyway.
Right. By default, it's just going to use the SSH keys available.
Right. So that comes to something else if we go here. So now we're going to salt SSH my minion test.ping. right, so if you notice, all right, we need to accept the key. And right here, to auto-accept, run salt SSH with the -i flag. All right, let's add the -i flag. We only need to add it once, and then it adds it to the known hosts, and we're golden. All right, so now it says, okay, I can't log into this minion with my SSH key, so would you like to deploy it? For now, we're going to say no, because I just want to show one more thing before we do that. If we want to just, sorry, if we want to just do password authentication, we can do two things. We can add the password to the flat file, to the roster file. I don't recommend that. Plain text passwords, probably not a good idea. Or we can just do, I need to start this time, test.ping, and we're going to do --askpass. Now it'll ask me for the password. It doesn't now. Thanks.
I'm sure somebody at Adobe fixed it for us.
All right, it worked. Okay, that is a fresh machine. I have never logged into that machine. I spun it up just a couple hours ago, and boom, it said true. Obviously, test.ping is not a very hard thing to run, but whatever. So now, so we know we can do it with passwords. The preferred method to run Salt SSH is just to let Salt SSH deploy its key. Okay, Salt SSH generates its own key pair and asks us by default, do you want to deploy this key pair? And yes, so I'll type in the password here. And it deploys the key and then runs the command that I specified. Okay, so now if we run it again, boom, okay? So now we're ready to just run whatever command we want to. I mean, we can do the normal stuff. We can command.run ls/, let's do that. Okay, we can disk.usage. You get the picture, okay? I'm going to assume everybody has a decent knowledge of Salt, so I don't need to show you all the common remote execution modules. Does anybody have any questions so far? We're going to talk about the deploy process and what's going on here next. Yes, it will ask you on a per minion basis when it's deploying. With --askpass, I think it tries to use the same password for all the minions in the run.
Just to repeat here, the question was, if you have 100 minions, is it going to ask the password for each minion, correct?
Yeah, so it's Salt SSH with, if you just want to work on passwords, it still needs a little bit of work to make it, really flexible. For the most part, I recommend just deploying the key. It just makes your life a lot easier. If you do --askpass, I think it will just come back and say permission denied on that 6th minion. If you're deploying the key, it should ask for the password on that minion.
So the question there again was, if you have 5 minions in a row that have the same password, and the number 6 has a different password with askpass.
I knew there was a reason we invited him. He's remembering to repeat the questions.
I'm here to keep him honest.
All right. Any other questions so far? Shoot.
Would this functionality ever be rolled into the main Salt code?
The question was, would this functionality ever be rolled into the main Salt code? And I'm not sure what you mean. In the main Salt code, the minions have their own keys, and we accept the keys on the master. There's no passwords involved. So,
But it seems it would be nice to have maybe 100 standard Salt minions.
Sure.
But there's 5 in your environment that you can only get to with SSH. So why not just have the Salt?
Have Salt have the ability to. So he was saying if you have 5 minions that are SSH and 100 minions that are 0MQ minions, shouldn't we be able to access all of them with the same Salt command? And that would actually be pretty cool and doable, I think. So I hadn't thought about that use case. Most people either use one or the other, not trying to mix them, but that would be useful. So we may add that.
Tom and I have actually had discussions on that because that is a very real use case. We don't have it in there yet, but it is on the roadmap.
About versions, Salt SSH 15 is compatible with Salt Master and Salt
So in this case, we're going to talk about the, sorry? Oh, good call. He asked about version compatibility. Is 2015.2 compatible with other versions? And that question actually doesn't really apply in this case because we are actually deploying the version of Salt that's on the master to the minions in a temp directory. And we'll talk a little bit about the deploy in just a minute. But if it will actually deploy the same version. So there's no version incompatibilities because you don't have an agent running on the minion to be incompatible. Any other questions?
Does this require an OS that's supported by Salt? If you have a proprietary operating system, use Salt SSH to run native commands in that operating system?
He asked if Salt SSH supports more operating systems or can be used with operating systems not officially supported by Salt. And the answer is yes and no. So things that, for example, grains that are expecting a certain operating system to detect and that kind of thing, those are going to break. You can, we have Salt SSH-R, which will send a raw command to our minions. So that will work on any system which supports SSH. We can say Salt SSH-R**, and we can say ls/.
In the very early days of Salt SSH, I was actually using it to manage Cisco switches, just using raw mode. Though it should be noted that you should cache the connection before you start issuing commands. Just because of the nature of the switches, you have to issue commands, then commit, and so on.
So you can see here that I just sent a raw SSH command. It's not actually running a Salt module. That stuff's going to work because we can send a raw SSH command to any SSHable server. But other modules and so forth that rely on grain detection and that kind of stuff will probably break. So the overall answer is no. But some things may work. So any other questions? All right, so let's talk about that deploy process. So Salt SSH actually reaches out to the minion and checks if Salt, I think it will actually use a previously installed version of Salt, or it was designed to do that at first, just search for Salt call on the target system. But with version incompatibilities, I'm pretty sure we just deploy these days. Anyway, so what happens is when we run a Salt SSH command, the master will actually compile what we call Salt thin, which is a thin version of Salt, which doesn't have certain dependencies like 0MQ, M2 crypto, these kinds of things that aren't required when we don't have to worry about transport. It basically pulls all of these dependencies into a tarball, which it then SCPs over to the target system, sticks in a randomized, secure temp directory, and then runs Salt call out of that temp directory. Which gives us basically all the power of Salt, but adds some overhead in the first place to get it out to the system. So if we look and we do, let's do Salt SSH * command.run, and let's do ls-a /temp. We can see that that's where Salt is deployed on the target system. No, he asked if when we did that again just now, did it copy another tarball over? And the answer is no. It will checksum. It uses checksums to make sure that we're running what we expect we're running, and it will check to make sure if I were to update my local version of Salt, then it would deploy a new tarball, but otherwise it will not. Man. So he asked if you wanted to force Salt SSH to clean up after itself. Okay? So in that case, you would do Salt SSH-W. Capital W. What that will do is it can actually be used with another Salt SSH that has already been deployed. It will randomize the temp directory completely and will clean up afterwards. So if we do Salt SSH command.run, let's do this again, okay, so we can see the directory there. Oops. Got to give it a target. So this will take it a second more because this time it has to actually deploy. All right, so it deployed temporarily to there. And now if we go back to here and use the other version that's in that root directory there, you can see it's gone. So if you want to just completely clean up after yourself after each command, you just use the capital W. If you want to just clean it up retrospectively, I don't think we have an easy flag for that. You would just remove the directory from your temp, which you can do with a salt SSH-R. So that's all question. Salt SSH makes it so that any system, he asked if you can only run the Salt SSH from the master. And Salt SSH actually makes it so that any system can be turned into a master if it has Salt installed on it, right? Because it'll deploy, any system that can SSH to other systems can be your master. So it can be your laptop, it can be.
Yeah, but in other words, you have to have, on the system you're running Salt SSH on, you've got to have all your SLS files.
Yes. He said on the system you're running Salt SSH on, you have to have your SLS files there and so forth. And yes, I will show you, we'll do some state runs in a little bit, but. That's true. All I did was install, with my Bootstrap, I did not use the -M flag, and so it did not install the master. That's true. Technically, it's interesting because we talk about installing the master in Minion. For most Salt installs, whether you're installing the master or the Minion, it's going to install all of Salt. The only difference between those packages, usually, is whether it installs the Salt master or Salt Minion, I'm going to say binaries, but they're actually just scripts into /user bin or wherever they're going on that target system. So when you install the Minion, you have all of the master code as well. You just don't have the Salt master binary. Does that make sense? So, yeah, even if you just installed the actual code from the source and didn't even install the binaries, you could call out to it from local client or whatever, and it would still work. Yeah, it'll probably install Salt Common and Salt SSH is usually how they're split out. Yes, Salt SSH can use the file server, and we're going to talk a little bit about that. I had trouble with the demo I was trying to do with getfs, so we're not going to use that, but excuse me, man. But yes, I don't know what's going on with the demo that I was doing, but we want to support all of the file server backends. So there may be bugs there, but we'll get them ironed out. Any other questions? All right. Let me make sure I hit everything. Did that. All right, let's go back to the slides for a minute here. All right, so we talked a little bit about how this is working. I didn't talk about the shim, however. So the shim is interesting. When you do as an SSH command, you can send over basically a bash snippet or bash script that it'll use with that SSH command. And so we actually have a very small Bourne shell script that executes our more featureful Python shim, so that we actually have the power of Python in our shim. So let's actually look at that really quick. Oh, that is the one requirement that I didn't hit on. It does need to have Python on the target system. At least Python 2.6 or greater. Obviously, it needs to be Python 2, 2.6 or greater. But very few systems don't have that, so we're in pretty good shape there.
Obviously, raw mode doesn't have that requirement.
Right, you can use raw mode even without that. So if you needed to install that, you could use Salt SSH with raw mode. install the Python and then deploy properly. All right. All right, so we're going to just look really quick. Oh, man, this is going to be terrible. All right. I'm used to having a dark one. Okay, so we're going to Salt. I just want to look at this really quick. All right, so we have inside of shell.py. Oh, this is terrible. And it's actually in init.py. Can you guys see that at all? Auto, you said? Autumn. Blue. Let's try blue. Yeah, that'll work. It's a little better anyway. It doesn't matter. We don't need to read the code. But basically, if you see here, we actually have the SSHShim, which is just this pile of shell script. Whoops. That time I coughed right into the mic, so just for you guys. Right here, we can see a line which basically we inject our Python code in there in base 64 encoded, and then we decode it and exec it on the target system. And that allows us to have an easier to use Python shim, which allows us to deploy and so forth. So we can look at that really quick. And this isn't stuff you actually really need to know, but it's pretty cool. So this is the actual shim, and it's actually pretty long, 223 lines, and it basically allows us to check for find Python on the target system, decide whether we need to deploy the salt thin, all these different things, and then we'll tell Salt SSH, it'll return deploy, just the word deploy if we need to do a new deploy, and then we deploy and run the command that we need to run. So it's a pretty cool system. It's a little bit out of the scope of this demo as to what's actually going on there, but I just wanted you to be aware of it if you ever want to check that out. It's all in Salt client SSH. That's where it is in the Salt code. So click to exit and go back in. All right. We talked about that. Oh, there we go. I did have the code dive in there. I just didn't check my color schemes beforehand. All right, so let's talk a little bit about the architecture. So 0MQ-based Salt is a push-pull. The Minion is connected constantly to the master, which means the Minion can at any time request files from the master, et cetera, run commands on its own. Salt SSH, however, the Minion is not ever aware of the master unless there's a command actually being executed, which means that certain jobs where we rely on interaction between the master and Minion, we need to do prep work beforehand so that interaction doesn't have to happen. And this was especially difficult with the state system. For those who, did I talk about that? Yeah. I don't know how familiar you guys are with the state system and how it actually works, but in 0MQ Salt, we tell the Minion, hey, you need to run this SLS or this high state. And the Minion then says, okay, master, give me the top file. Okay, I'll compile the top file, figure out what I'm supposed to run out of the top file. Okay, give me this state and this state and this state. Master sends those files down. Okay, we're going to compile these files, and then we run the states. All of this happens Minion side. And so it was actually a real challenge to make that compilation process possible on the master side, because we have to do all of that compilation and get it down to what we call a low state for those who are available or who are familiar with the state system. We have to do that all master side. And we have to inspect those states and say, okay, these states are going to need this file from the file server, and this file, and this file, and this file, and we need to stick all those in the same tarball that we send down there and have the Minion execute, because it can't request files from us mid-state run. We have to give it everything right from the beginning. So this is where the wrapper functions come in. So basically, the wrapper functions are located in, I'll use less instead, and that would get rid of the need for wrapper. All right. So we have the wrapper functions. Basically, anytime any Python file that we stick in that wrapper directory will replace its counterpart in normal Salt. So we have a state.py in here. So we have SLS. We have state.sls. We have state.highstate. And they're all defined in here. And now, because when we run a command with Salt, it'll say, okay, is this a wrapper function or a normal function? And if it's a wrapper function, it's actually going to run it on the master. Before it does that, it's going to do some extra work. It's going to check in with the minion and say, hey, and ask for the minion's grains. It's going to generate the minion's pillar. It's going to generate all these things that we often need for state runs and so forth. And so that actually adds a fair amount of overhead to these kinds of runs, but it's not terrible. It actually works pretty well. So some of these wrappers, let's just look at the list here. So again, anything where the minion needs to talk to the master, that's where the wrapper functions come in. So cp.py, mine.py, publish, the states. All that stuff is in a wrapper function and executes on the master. Yeah, so we're not going to... This stuff is pretty hairy. The wrapper functions can be a little hairy because, again, we're trying to shoehorn things that were meant to have push-pull with only a push architecture. So we're not going to go into the actual code, but we are going to demo a state run here in just a minute. Before I demo it, I just want to talk a little bit about the state system. So, yeah. The 0MQ system is based on Python.
And you're creating a miniaturized version of Minion and sending it. Is there no reason why you don't also send the 0MQ and you create a tunnel back to the master and then have the push-pull available to the SSH?
So he asked, why don't we just push 0MQ down and install the Salt Minion properly and create that, well, I guess not install the Salt Minion, still run it out of temp. And then just have that push-pull available. And that would be potentially possible. You run into issues where we don't want to be in the business of trying to push down the correct 0MQ binaries, which 0MQ is C. It's not Python. So we need to use the package manager and install it. And now we're no longer leave no trace, right? And at that point, why don't you just install Salt? You know, I'm pretty sure that was what Ansible's Fireball mode was trying to do. I don't think they're maintaining that anymore, but we figure we want to get feature parity and be able to leave no trace, and if you want to do the push-pull, then just install Salt. Does that answer your question? All right, so the state system, and I will take more questions in just a minute. I just wanted to talk really briefly. The state system works, and it works really well. There are certain caveats, especially in performance. When you have a state that is templated and has Jinja calls to Salt, the Salt dictionary inside of Jinja, so you can call out to other Salt modules, each one of those calls will create a new SSH session so we can actually run it on the minion, get the return, and then put it into the template. Okay, so that's one thing to know. Each time you use that dictionary, it's going to create a new SSH session. That adds some overhead. There are certain other things that are incredibly, they take a huge performance hit, and these are things like publish or mine calls, which the mine is the big one. A lot of people are using mine these days to get data from other minions into their state runs. The way the mine is currently implemented in Salt SSH, for each minion, we will create a new Salt SSH session with all the workers and everything and call out to all the minions, get that data back, and template it. And we'll do that for each minion that's running the state run. So it's kind of an exponential effect. Eventually, we want to try to get a caching system into place so that it's not quite so bad. But there's race conditions involved there because this is all running in different processes and different worker processes. So currently, we just wanted to get it so the mine is working. And it is. It just is fairly slow, especially as you add more minions to the state run. So just keep that in mind. And yeah, let's look at this. Oh, and then the one other thing that you have to think about with the state system. Was I ready for that? Oh, okay. Actually, let's just look at this slide while I continue talking. The one other thing to think about is if you have a file.managed and that file is a templated file and needs access to another file. So I have a file.managed with a source from salt://. Inside of that file, I have a Jinja import or something to import a map.jinja like you do in the formulas. Salt doesn't know to send that map.jinja file down, and so we have to specifically specify and tell Salt that it needs to send that down with the state run. And we do that using a configuration option called extra file refs. So we basically can just give Salt SSH a list of file refs that it needs to send down with the state run in order to make it work. All right, so let's just test that out. All right, so let's go back to my master here, maybe. All right. Can we still see that? We're good? So I'm going to actually go over here and grab the Apache formula. So this is not a hugely complicated formula, but it has a fair amount of states in it and some Jinja and so forth. And so it'll give us a good idea of, what this looks like and the fact that it actually works. So let's go to /serve, and we're going to just clone, maybe, that to Salt. Again, I tried to make this work with GitFS, but I didn't have time to debug why it wasn't working, so we're just going to clone it right in there. Okay. We need to also make a pillar directory and copy salt/example.pillar, or pillar.example probably, to, we'll call it apache.sls. Need to create a pillar top file really quick. Simple stuff here. And this has some extra stuff that we don't need, so I'm going to get rid of that as well. All right, so we've got some sample pillar that was provided with the Salt formula. This is the Apache formula, the official one. All right, so we've got the pillar there. In fact, we'll just test salt SSH star pillar dot items. I don't remember what that less pillar Apache. I think it was just Apache. Okay. So we can see that the pillar is actually being generated here. It does. Salt SSH does have a -v option. The -v actually doesn't give us the SSH stuff. It just gives us the JID and so forth. We can also we can change the log level. However, debug log is currently very verbose. It actually prints the entire shim, including the base64 encoded Python stuff. So, I'll show you, because why not? But it's less than useful right now. So that's something we want to make more useful in the future. But it does have good information there. You just have to sift through the extra. Right now it's generating grains and pillar and so forth. All right. Anyway, so we can see that we have pillar data. So now we can say, okay, I want to do, okay, so the one other thing we need to do, etc salt master, which doesn't exist because I didn't install the master. We just need to define extra file refs. And this is just a list. I'm just going to put salt://apache/map.jinja. Because I happen to know that file gets used by some templates in the state run. So now, every state run I do, that file will get sent down with the state run so that it's made available to whatever needs it. You can also pass those in right on the command line with your state run. So let's do this. State.sls Apache. Oops, I did salt. Stop. While that's going, I can't remember the other command. vhost standard, that's what I wanted. Like I said, there's more overhead when we do a state run. We have to reach out to the minion, generate its grains. We have to generate the pillar. And then we compile it all on the master into what we call a state package, which is just a tarball with the low data for the state run, which is what the minion needs to actually run, as well as the files that it needs in the file server. And you can see that it installed Apache, no problem. Made sure the service was running. Yeah, so we're good there. So let's try Apache dot. Let's add a couple of virtual hosts. I think I only defined one, but this will use a little bit more templating. It has, a virtual host file that is templated with the data that we provided in Pillar and so forth. All right, 6 succeeded. So we can see it still checked for Apache to be installed and server start running because it included those states. But now we stuck example.com into our sites available. We enabled that site. We reloaded. And I don't know why the service restart is there, but I guess it needs to restart under certain circumstances as well. Yes, it is. And we can see if we run it again, just like any normal salt state or any normal state should, we'll see that we should have changed equals 0 this time because states are idempotent or idempotent, however you want to pronounce that word, because I've heard it both ways. Ta-da! States work in Salt SSH. So obviously, there are still bugs to be worked out. There are some open ones on the issue tracker that I'm slowly working through, and we'd love it if you guys tested it and continued to report more bugs. But yeah, that's it for my demo, so I'd love to take some questions. It runs in parallel. You can define the number of worker threads. Oh, yeah. So he was asking, is it, we're running on all of our minions. We only have one in this case. But if we had lots of them, does it run sequentially in parallel? And we can say Salt SSH here. And we can say, okay, we have, where are we? Max procs. So that's the number of concurrent SSH sessions we're going to open with minions. And it will just basically has a pool of these processes and will only be running 25 at a time by default. Another question. We haven't looked into, he was saying, why don't we have push-pull over the SSH tunnel? And that is something we've talked about, but I don't think it's currently on the roadmap. I think it would be something we might like to do in the long term, but.
Yeah, I think there's been some recent discussion on the mailing list about that, but it's been very recent.
But that is something we've considered. We just haven't gotten around to speccing it out or anything like that.
Another question back here.
So the question was, if you wanted to lock down sudo access for Salt SSH, what process is it running? On the target system, it's actually going to be running, well, it's going to be running the shim that it sends down, but it's going to be running saltcall, basically, out of that temp directory. Does that answer your question? Whatever command you sent. So, it's going to be saltcall command.run ls/temp if that's what you sent in, right? It'll have some other flags. It'll have -c with the config file that we sent down, and it'll have, but at its most basic, it's just going to be running the command that you ran with Salt SSH. Questions? Right, so the question was, how many hosts can you have in the roster file, and does it run concurrently or sequentially? And like I mentioned before, it does run concurrently up to max procs at a time. And there is no theoretical limit to the size of the roster file. It loads it into memory, so you have that limit. It's just going to take it a while because it only runs 25 at a time, and we saw how long it takes about, to run a test.ping. So running a test.ping on 1,000 minions with only 25 at a time, it's going to take a couple minutes, but it will get there. Does that answer your question?
So, we were hoping we could use Salt SSH for Cisco devices. We can dash our host and type that.
Did you say you did something with Cisco devices?
I did use raw mode with Cisco devices, but something else you may want to look into are proxy minion modules. If you want to talk to me about that offline, I can give you some examples and show you some docs. What's that? Right. It basically treats, it has one minion act as a proxy for another minion, and the first driver that was implemented for that was for Juniper devices. I'm not sure if we have Cisco in there right now, but Cisco's been on the roadmap.
Any other questions? So the question was what user is it running under and so forth. And yes, it's running under mine. If I were not running as root, if you remember, Salt SSH. It will run under your current user, and it actually installs. This is the target user. So if I was, it's interesting because if you have a minion and you want multiple people to be able to control that minion with Salt SSH, and each of those people have their own user accounts on that minion, they can run in parallel, and it will just deploy to a root directory or a base PI directory if that were my user on that target system or whatever. But yeah, locally the SSH session runs under your user ID, but.
An example is we use our account to log into a server, and then based on what we do, either SHU it or SU at that server. So if you did the same thing here, if you log into Excel and did Salt SSH to that host, it's going to set up under your account. Can you control that?
Ask me, come up after, we need to wrap this up, and I will answer your question offline. Any other questions really quick before we wrap up? I'll be around, so come catch me if you have any other questions. Thanks, everybody.